over this review, and then we're going to take this quiz. Okay, so everybody should have this in front of them right now. There shouldn't be any other talking going on right now because you should all be paying attention. We're going to go over this. Okay, so the first thing we're going to do is find the range for this set of data. Okay, the range is the biggest one minus the smallest one, so the range is 2. Excuse me, the range is 5 minus 1 is 4. The range is 4. I don't know what I'm talking about. Okay, next, we are going to get our calculator out. And we are going to go through how to put this data into our calculator to find it. Okay? So I'm simply going to go to my calculator. I'm going to hit Add a New Document. I'm going to hit 4, Add Lists and Spreadsheets. I'm going to go above the gray line and hit X. Then I'm going to go below the gray line, and I'm going to type in all these numbers. 3, 5, 1, 3, 5, 3, 1. Okay, so I've entered all of them in. Then I'm going to hit Menu, 4, 1, 1, okay, okay. And I'm going to find that the mean is 3. How else could I have done the mean, guys? I could have added it all up and divided by how many there were, right? If you hit Control Doc, a new page is added. We can add data and statistics, change this to X, and it kind of shows you how the graph looks. So what's the shape of this graph?
Symmetric.
Symmetric. Okay, so now with this symmetric data, you can go ahead and find the standard deviation. Now, the standard deviation is in your calculator, but if you see a chart like this, you do have to fill it out to get full credit. So I know the mean for all of these is 3, so I could fill that straight out. Pretty simple. Then I'm just going to subtract 0, 2, negative 2, 0, 2, 0, negative 2. Then I'm going to square this row that I just did. 0, 4, stop talking, 4, 0, 4, 0, 4. Now, I'm going to add them all up, and I get 16. How many different numbers are there? 7. So I'm going to place this here. 16 over 7 square rooted gives me 1.51.
You just put like 16 over 7 square root in your calculator.
Okay, now I want to know which of these fall in one standard deviation. Okay, so I'm going to take my mean, which is 3, and I'm going to add 1.51 to it. Okay, this gives me 4.5. And then I'm going to take my standard deviation, mean, and subtract the standard deviation from it, and I get 1.488. Well, I know to get one standard deviation, it has to fall between those points. So I took the mean and I added the standard deviation. I took the mean and I subtracted the standard deviation. And then I said, which of these numbers fall between one standard deviation? So it's greater than 1, but less than 4.5. So those 3 numbers are between the standard deviation.
What is it?
Nope. You do. The mean, which is 3, plus the standard deviation. And you do the mean, 3, minus the standard deviation, both of these. And that's how I come between 1.488 to 4.5, somewhere in between there. Yeah? I added it all up, divided by how many there were. All of these numbers up here. Okay. Next, this is what we talked about yesterday. Drawing the normal distribution. So remember, with my normal distribution, it goes like this. This right here is the mean. Then this is 1 standard deviation away, 2 standard deviations away, and finally 3 standard deviations away. So a company, if you could turn off your phones, please, that would be great. If the median of the salary is 35,000 and the standard deviation is 7,500, how do I get the first standard deviation here? What am I going to do? I add 35,000 plus 7,500 is 42,500. And then how do I get the second standard deviation? You add it to the first one, right? So 42,500 plus 7,500 gives us 50,000. And then I take 50,000 plus 7,500, and I get 57,500. Okay, and I want to go the other way. So I have 35,000, and I'm going to do what to get 1 standard deviation to that? Minus, and I get 27,500. Then I take 27,500 and I subtract 7,500 from it, and I get 20,000. And then I take 20,000 and I subtract 7,500 from it, and I get 12,500. Okay. My brother makes $18,000. Does my brother's salary fall between 1 standard deviation of the mean?
No. Wait, how?
Because see, this is 18,000. Is 18,000 between these?
So are those the only ones that really matter?
Well, if it's 2 standard deviations, you would be looking from here, right? Okay? Should he ask for a raise? Why? Because he doesn't even make within 2 standard deviations. Okay? Okay, let's turn it over. All right, here are some sample test scores from an Algebra 1 class. Make a dot plot of the data, then answer the following questions. So we've got 80. We've got 93. We've got 60. We've got 65. We've got another 60. We've got 70. We've got 62. And we've got a 98. Okay. What is the range? The smallest, the biggest minus the smallest. What do you guys get? 38. Shape of the graph. Is it symmetric, skewed to the right, skewed to the left? Skewed to the what? It's towards the right, so we say the left.
Will you explain this?
Yeah, if most of the numbers are one way, you say the other way. Oops, sorry, this is not. Most of the numbers are right here, right? They're on the right, so on the left, so I say the right. So it's skewed to the right. It's whatever the opposite is. So just look at the data. Are most of the numbers over here or over here? To the right or to the left? So you have to say the opposite. Say they're to the right.
And then, what other, like, when would it ask you that again? Like,
Shape of data. Whenever it's a shape of data.
well, how do you figure it out on, like, other things?
Same way. If it's more to the right, you say skewed to the left. If it's more to the left, you say skewed to the right. If it's symmetric, you say symmetric. Okay, what's the mean? How do I figure out the mean again? Add them all up, divide them by how many there are. Or you can just put in your calculator. I get 73.5. I would totally put this in my calculator because then it asks me all these questions. It asks me the standard deviation but doesn't leave a graph like a table. So instead, I'm going to put it in my graphing calculator. Okay, I'm going to add a list again. I'm going to go up, I'm going to put an X. I'm going to go below, I'm going to put 80, 93, 60, 65, 60, 70, 62, 98. Make sure I hit enter. Then I'm going to hit menu. Then what? Then what? Then? And then? And then? And I'm going to look for, my mean is right there, 73.5. My median is harder to see. This is where I would add a new page. Adds data and statistics. Click on X. And then I would change this to a, which plot type shows you the best median? Box. Okay? And then you just go over this little line right here, 67.5. Okay, the mean is greater than the median. Okay, standard deviation. Remember, is that little funky O thing with an X is 14.15. Okay, a basketball coach kept track of how many baskets on average each of the players scored during a game of the current basketball season. The data is shown below. We're going to make a histogram. It already gives you all the frequencies. So you're going to say between 0 and 2, you got 1. Between 3 and 5, you got 1. Between 6 and 8, you got 1. Between 9 and 11, you got 2. Between 12 and 14, he got 3. And between 15 and 17, he got 2. Okay. According to your histogram, what is the shape of the data? Shape of the data. Symmetric, skewed left, or skewed right? Skewed left, right? What would the mean be in relation to the data? To the median. Remember, if it's skewed to the left, your mean is less than the median. It's just a rule. If it's skewed to the right, your mean is greater than the median. If it's skewed to the left, your median is greater than the mean. If it's symmetric, they are equal. Because I gave you a rule about it in your notes. Yep. Sure were. Yeah. Can I go back to what? Number 3. Yeah. Anybody else have any questions? Okay. I'm stopping the recording. We're going to take your quiz, put everything in your backpack, put your backpack at the front, including your phone.